Good afternoon, everyone, and I'm delighted to welcome you all to this IBioIC conference fringe event. Great to have you with us this afternoon. And this is in collaboration with Scout Project and Life Sciences Scotland. So we've got a really packed agenda for you, which I'm going to pop into a moment or two. But my name is Arlette Halavaj. I'm a member of the Sustainable Production Group, which is one of the work streams in the Life Sciences Industry Leadership Group. And I've actually got some colleagues who are part of that Sustainable Production Group with me here again today. So if we move on to the agenda, so we're going to start by sharing just some information about life sciences in Scotland. And then we're going to move on to the Sustainable Production Group. And I'll share some information with you on the priorities that we're focused in on. And then we are going to cover some information on the Scout project, which is really important information because it's free opportunities that you can tap into. So I'll share a little bit of information about that. And then we're going to move into the majority of the agenda, which is some really fantastic showcases of pioneering activities within the green value chain and some brilliant work that we hope that we can take away, learn from, and perhaps think about applying in our own network and organizations. So with that, I am going to move on to life sciences in Scotland. And you may be aware that this has been defined as a priority sector of economic significance by the Scottish Government, which is just absolutely fantastic. And we are one of the world's most dynamic global clusters for life sciences, which is something to be hugely proud of. You may also be aware that we have an ambition to grow the sector from 4.5 billion in 2014 to 8 billion by 2025, which is a great ambition to have. But I know for many of us, it's more than just that growth. It's the impact that we can all have through the life sciences sector on humanity. The sector employs over 40,000 people across more than 750 organizations. So we have a huge network that we can tap into. We have world-class innovation that has the potential to create high growth, and that's matched by really powerful networks. Some of you will have taken part in the conference earlier today, which is one such of those networks that we can tap into, and a fantastic infrastructure as well. So physical infrastructure, supporting organization, and a great appetite across all of that for collaboration. The Industry Leadership Group itself has 8 work streams, and I'd mentioned that the Sustainable Production Group is one of those. And all of those work streams are working towards delivering that life sciences vision. So if I move on and talk a little bit about the Sustainable Production Group, which is really close to my heart. I'm so passionate about being involved in this, this work stream. So it has been running since 2017, and we have 3 priority focus areas that we're working on, which we call our subgroups. So the first one is focused on digital. So this is about promoting digital and data excellence in manufacturing, and really making sure that we share best practice. We have some brilliant examples where we have applied digital and data excellence and unlocked potential of organizations. So this subgroup is looking to leverage digitalization in the support of developing the life sciences sector in Scotland. The second key focus area for us is leadership. And I work with some of my colleagues in the room on this really important topic. So we host an annual leadership masterclass, which is available to high potential emerging leaders in the life and chemical science sectors. And we're really trying to build very quickly the leadership capability of emerging leaders who have the potential to be senior leaders within those sectors within the next 5 years. So really helping them to become transformational leaders of the future. And the third area, which we're really going to focus in on today, is innovation. And we've got Ewan with us today, who really leads on this subgroup for the Sustainable Production Group. And this is about advancing innovation in sustainable manufacturing across Scotland. So really, really important key area for us within the Sustainable Production Group. So I move on to the Scout project, which many of you are probably aware of, but just some additional information for you. The Scout project does aim to help SMEs, so small and medium enterprises, de-risk their technology development. And there are some great partners that we can tap into with world-class capabilities and innovation expertise to help on that journey. It is funded by the European Regional Development Fund, and it is administered by Scottish Enterprise, and I know many of us in the room will work very closely with that group. It's open to all Scottish SMEs who operate in the chemical, biochemical, or life sciences sectors, and the great news is it's an opportunity to tap into free support. And there are three key areas on offer in terms of support which you can tap into. So I'll just share a little bit more about each of those. So the first is Innovation Forum or events. And these are workshops which cover key industry challenges that you may be experiencing. Also enabling the development of networks, so making sure that we connect to enable collaboration, and it also helps us to build supply chains within our sector. The second area that you can tap into is called Innovation Integrator. And this is really a business consultancy tool which provides SMEs with an objective review of products or processes that you may be pioneering. It's a one-to-one engagement, so it's really focused on the work that you're doing, and there are 12 factors which are considered, so it's a really robust review. And it covers anything from the very original invention idea right the way through innovation to the point of collaboration, so right the way along that journey. And then the third area is deep technical consultancy, which enables you to tap into guidance where there may be particular challenges that you're trying to solve, enables you to unlock diverse expertise that can support you through the partner organizations that you see here on the left-hand side, so CPI, CMAC, and indeed IBioIC. So great opportunity to tap into that support. So we're now going to talk about the green value chain, and I mentioned this is a really important part of the Sustainable Production Group and the work that we're doing. We know that the Industry Leadership Group are fully committed, as are we all, to minimizing the environmental impact from the development, the manufacture, and the delivery of healthcare. The life sciences sector is absolutely cognizant of the role that it has to play in responding to the climate change emergency that we have. And through working together, we can make a significant contribution to the sustainability agenda that's so important to us all. And today we're going to hear some showcases where some pioneering activity is taking place in this space. So this is our green value chain. So you can see that it really is starting at the very inputs to our value chain, working through manufacturing, how we package our products, right the way through to the point of delivery of the product to the relevant customer. So today, we've got some brilliant showcase examples where companies are working in the different parts of the green value chain, and they're going to share with us the brilliant work that they are doing to support net zero and also the wider environmental sustainability space. So we're going to jump into those showcases now. Now, each of the organizations that are sharing with us today only have 4 minutes, which might seem like a long time, but the reality is it isn't very long at all. And so if you do have questions, I'm sure you will have some questions as we go through today's presentations. If I can just ask you to hold on to those, please, until the networking session at the end, and then you'll have the opportunity to ask any of the questions that you may be pondering over. So with that, I am going to hand over to Alex and IBio, who are the first showcase for this afternoon.
Excellent. Well, thank you very much for inviting me to speak. I'm Alex McVeigh. I'm one of the co-founders and the CEO of IBio. We were a company that was formed back in February 2020 to revolutionize how microbes are grown and analyzed. And so I'm going to talk a little bit about how we do that, but also a bit about what our motivations behind some of that are doing in the first place. And I mean, we're moving away from fossil fuel production. We're looking to make it more green and sustainable. But in doing so, one of the biggest problems that we actually have is that plastic waste in laboratories is a really big problem. About 5.5 million tons of plastic waste is generated by research laboratories every year. A study at University of Exeter found in 2015. And that equates to about 67 cruise liners worth of stuff, or as I prefer, my go-to weight measurement, about 400,000 elements. And that's a huge problem, of course, because these single-use plastics are single-use. They're going to waste, and we're not really protecting the environment with that. And so what we've done at IBio is we are trying to automate and increase the ability of our customers to develop new and innovative new products that will enable them to reach this green, these green targets, but also to make it more affordable and sustainable for them in their own right. So we have developed initially a modular automation system, which if you were at the talks yesterday, you will have heard me mention briefly. It's a system that's designed specifically for microbial culturing. It enables you to replicate the conditions that you would see in the R&D flasks, and enables you to, with a low cost of buy-in and running costs as well. But further than that, it allows our customers the ability to chop and change and makes the flexibility of the system. They don't have to specify exactly what they need at the point of purchase. They can add and adapt and be flexible to it. And that reduces the waste of equipment being purchased and sitting idle in the research laboratories. So they can pick and choose the features they need. And beyond that as well, we want to improve the information that you can get from your experiments, so you can get more targeted, increase the information you get, make it more relevant, make it more useful to them, and therefore reduce the time that it takes to bring these products to the marketplace. And we're doing that through a series of products that I don't really have a lot of time to talk about, but if you want to find out more about them, please do come and find me afterwards. But beyond that as well, we're really looking to make our business itself sustainable. And what our ambition is, and we're by no way anywhere near there just yet, is to offset all of the carbon that we use in making the devices. And actually here is something that I was talking to a couple of companies recently that I just want to highlight their ability to do so. Small 99 is a company that's set up specifically to help SMEs and early stage companies to look at how they can make positive choices in their companies' developments to enable them to reduce their carbon footprint, to make sure that they are also making the correct choices for the environment as they're looking to drive their innovation. And companies like the Future Forest Company, which is actually owned by one of my friends, so a big shout out to him. He is not just planting trees and making life much more sustainable, but he's also doing carbon capture and making a positive impact as well, not just net zero, but actually returning carbon back into the environment. Our aim, of course, is to manufacture our products completely at net zero, and where we can't do that, we want to offset the emissions that we are producing, whether that's in the production of the materials that we're making, or actually in the everyday operations of our devices and everything else. So thank you very much, and I'll pass on to the next one.
Thank you very much. Thank you, Alex. Brilliant. So if I could invite Nikos from Impact Solutions, please, to come up next.
Good afternoon, everyone. Thank you very much for inviting me here to talk today. I will be presenting the project that was undertaken last year in collaboration with IBioIC and University of Edinburgh, Dr. Stephen Wallace. And this project was looking to basically evaluate the feasibility of replacing one petrochemical feedstock for a bio-based feedstock coming from fish waste. Before I do that, I'll quickly introduce you to our company. Impact Solutions is a testing laboratory and innovation center. Recently, we've acquired a new space in Livingston. We used to be situated in Grangemouth. Now we've outgrown the space. We have this new facility, and we offer a small space as well for companies that can come, the startups, an incubation space, office space, but also a range of analytical laboratories and mechanical testing. If you want to hear more about it, I will happily talk to you about that later. So how this project came about. Originally, we focused on two of the issues that we are currently faced with. One is the fish waste production from the fishing industry, and the other one, the fossil fuel based production of one of the most important dicarboxylic acids, that is adipic acid. This is mostly used in the production of nylon fibers. It is estimated in 2020 the world produced about 62 million tons of fish waste just for the production of fish, but obviously that's downsized in Scotland. The numbers are orders of magnitude smaller, but still the percentage can be translatable. Another thing, of all the fish that's been produced, further processing produces more waste, and this is part of the inedible parts that we cannot eat or we don't use in this country. Now, another issue with the production of adipic acid is, of course, that it's based on a petrochemical feedstock, as I mentioned earlier, but also the greenhouse gas emissions that are associated with an energy-intensive process, as well as nitrous oxide. Now, what the thought is, we can combine these two. We can basically use a mechanical enzymatic treatment by using enzymatics that are basically commercially available to treat the fish waste, extract the valuable fatty acids, we characterize them, and then by introducing these to a genetically modified system of bacteria that can express the enzymes that we want for the further biotransformations, we were able to produce adipic acid in lab scale. Now this is great. So this project helped us see if that's feasible in a larger scale. Unfortunately, it wasn't. The economics of it didn't work, and that's fine because that project gave us the capability to make a very strong collaboration with Edinburgh University. We characterized this feedstock because this feedstock is quite problematic. People are talking a lot about, in Scotland at least. And also we were able to explore new areas and avenues that we can work on. That all led to a new project application with a very big player, Lubrizol, to look into further biotransformations of such feedstocks into something more valuable. And we were still basically waiting for the results, but all going well. This is going to be fine. So yeah, thank you very much for your attention. This was a very short presentation, but please come and find me later.
Fantastic, thank you. Thank you, Nikos. And next up we have Nitec Solutions and Rui, please.
Hi everybody, my name is Rui Wells. I'm a process development chemist with Nitec Solutions, and I'm here to talk about how Nitec helps companies in chemical manufacturing, pharma and life sciences reach net zero. Bit of background on Nitec. Nitec was founded in 2004 as a spin-out from Heriot-Watt University by Professor Jean-Wei Ni. And we provide innovative, continuous reactors and crystallizers as an alternative to conventional batch processing. So, as you can see, we produce across the production scale, right the way from lab scale to full production. All of our units are continuous oscillatory flow, so the flow flows in both directions through the reactor and has baffled tubes. So we have enhanced mixing and heat transfer throughout our lab, pilot and production scale units. This allows for longer residence times and more consistent product quality. So we add to the green value chain in three key ways. We help companies reduce their CO2 emissions with reduced energy consumption. It's a lot more efficient to heat and cool a small Nitec reactor compared to a large 300,000 litre batch vessel. All of our units have a much smaller footprint than a conventional batch reactor, So we can fit our units into existing sites that might not have expansion capability, and we can also offer a distributed manufacturing model, which reduces on distribution costs. And because our reactors have much better mass and heat transfer, we get a lot more efficient reactions. So there's far less waste of raw materials and far fewer impurities coming out at the end. So an example of a NETEC reactor in action. So this is a full-scale production reactor that Sanofi installed. They're producing an API known as Renagel, and it used to be made in a 300-meter cubed batch reactor, which is a huge volume. It'd probably fill half of this room at least. We replaced it with a 0.2 meter cubed NETEC reactor. So, I mean, that's a factor of, order of magnitude 4 difference there. We also get more consistent product quality out of it. We can have more accurate input dosing, so we're wasting less raw material, reduced energy consumption. In addition to this, we also have another reactor that's being installed with another UK life sciences company that's due to be online in the next couple of months, and we're very excited about that. Final example to show you, some collaboration work on a power to methane project. So this is using waste gas from industrial processes, CO2, and hydrogen formed from electrolysis using renewable energy. And we feed the hydrogen and CO2 into a bioreactor with bacteria that convert the gases into methane. This methane can then be stored, or it can be injected straight into the gas grid for reuse, creating a circular economy. Using a NETEC reactor, we get highly efficient bacterial conversion of CO2 and hydrogen to methane, and this is much faster and less energy intensive than conventional batch processing. So if anyone has any questions about what we do as NETEC, I'm more than willing to speak to any of you, and thank you very much for your time.
That's great, thank you very much. Thank you, Rory. So we've now got Neil, from IBioIC.
Hi, thanks everybody for letting me present here. I've just come out the other end of the IBioIC conference, so it's all very interesting stuff, and there's a lot of connection points here. We're different. We're not a manufacturer of a specific piece of process equipment. We develop projects. And so I'm the managing director of a Scottish subsidiary of the Abbey Group called IBioIC, which was formed in 2015. I'm a weird character. I'm a chemist, process engineer, chartered surveyor, and a strategic marketer. So how the hell did I end up here? Well, one day I was looking out of my office window up in the far north of Scotland on that site, which is a former US naval communications station, which was redeveloped 2004-05 for helping decommissioning of the nuclear supply chain, because the Dounreay site is just further along the coast there. And we have a wind farm there that's been there for quite a while. And I was looking out through the window and I thought, all that power, and we don't get any of it on site. And I thought, well, that's typical of Scotland. We have all these wind farms, we have all this large generation, and it all goes south through the transmission network, and we don't do anything with it. So what can we do? We're far north of Scotland. We get great solar resource in the summer, but not so good in the winter. So there's all kinds of combinations and things we could do. And so we started looking back again at anaerobic digestion with the whiskey industry, because we've got quite a number of distilleries within 50 to 80 miles. And that seemed to be quite a good approach. So, So in 2008, we decided to look at a novel approach to AD. When people talk about scale, they always think, oh, well, you're trying to get bigger. We're trying to get smaller, because there's a big chunk of the Scottish whiskey industry, which we would call small to medium-sized distilleries in rural locations. The big boys, the Diageos and the Grissans of this world, will create treatment hubs, and they're hoovering up a lot of the feedstock materials. But there's a big rump of the industry that's still dealing with practices from 100 years ago or more, discharging stuff to sea, spreading stuff to land, and they're sort of sandwiched in the net zero strategies between CEPA on one end, saying you've got to go beyond compliance, and climate change affecting things so that they can't spread to land. It's getting wetter in winters. So up we popped naively, thinking, let's speak to companies like Inverhouse Distillers, who've got a distillery in Wick, and find out what the problems were. And they've already dipped their toe into AD and had some interesting experiences. And they would rather have a developer come along and take the risk and look at technology assessment. So we started on that road, looking at That's a modular 16,500 cube a year AD plant, a CSTR reactor. And we're working with a company called Envirochemie in Germany, which is part of a much bigger group that have some novel separation technologies. And I'm interested in some of the other speakers' inputs today, so we can network later on that. But it basically sets up an energy hub which powers our site, and then we can tie in bioenergy developments. The gas engines we're using are hydrogen enabled, so we can blend up to 40% in the future because we've got all kinds of renewable stuff in the area, and Orkney just over the water have already using the same gas engines for hydrogen projects at Kirkwall Airport. So it ties in a sort of a network where we can take on additional projects. And I'm trying to look at things we can do with IBioIC and other groups, hence why I'm here. So biogas and circular economy, it's kind of waned and ebbed and flowed as to how useful it is, but we see it as a transition gas. One of the routes to blending with hydrogen or using as feedstocks in other ways. So the wider benefits of the project is regional hubs for low carbon and biotech, energy accelerator programs with SMEs tying in. We'll work with anyone within limits. And we're looking to replicate this. So we had to get an investment model together, and we've got investors on board. And it's very difficult to put an investment model together in this kind of area. We've got lots of integrated technology compared to wind farm development, solar development, which are fairly linear. You know what you start with, you know what the investment returns are. So I've spent a lot of time creating models to say, this is how all the parts work together. And then there was a damn war in Ukraine, and the energy prices went through the roof. So that actually helped in some ways, but it changed the model.
Thank you so much. That was great, Neil. Thank you. Yep, so we're now handing over to Ewan and Cohesion Medical.
Hello, everyone. In 2020, the NHS published its NHS Carbon Footprint Plus, of which 24.9 million metric tonnes of carbon dioxide were emitted. 62% of that were due to suppliers. But actually, most interestingly, 14% of it were due to citizens. And those were citizens making travel and visits to outpatients at hospitals. At each health point, there's significant and complex logistics, costly overheads, and effectively unnecessary carbon emissions. I'm Ewan Cameron. I'm the CEO of Cohesion Medical, and we're developing innovative digital solutions to reduce the carbon footprint of service provision and drive net zero in citizen health. Cohesion is a multi-award winning digital health company based in Glasgow. Unlike biotech, which goes from research to the real world, we're more tech bio. We develop real world technology systems that drive data insights back to understand complex biology. This opens and unlocks new opportunities for life sciences, for population health and precision medicine. Our solutions simplify that connection between citizens and the services and the sciences that they interact with. We've developed a citizen care wallet, a mobile cloud app that allows for managing complex, multiple conditions, multiple services, multiple users, and connecting with multiple devices, as well as a service platform that's configurable to multiple healthcare providers and multiple multidisciplinary teams, and connecting those to a communications data bridge that allows communications between services and citizens to services. And wrapped around that, we have a big data analytics technology that allows us to analyse the data traffic in quite considerable depth. We've been applying our technology in multiple areas, working with partners in NHS England, Scotland, academia, national charities, community health, as well as other technology providers. And we've been applying it in different areas from chronic care conditions, such as inflammation, through to brain health and dementia, right through to end of life. As one example of the work we've been doing is in remote monitoring for hypertension, been working with Community Pharmacy Scotland and 280 pharmacies across Scotland, and with support from the Digital Health Institute at Strathclyde. What we've done is give patients our wallet to allow them to manage their symptoms, their health and wellness, and allowing them to connect with a blood pressure cuff using Bluetooth enabled to pass data from blood pressure readings onto our device, and then allowing them to connect with any pharmacy across Scotland of their choice. That allows them to connect and share data that they're collecting from their device and their phone with their pharmacy provider. For the pharmacists, we provided the pharmacy digital platform, allowing them to remotely monitor these blood pressure readings, but also a data early warning system that allows them to detect health trends and patterns that wouldn't normally be visible to even GPs and consultants. And in addition to that, we've built in a clinical decision support system to allow them to guide interventions and appointments to a more appropriate way. And at a higher scale, what we've managed to do is unlock new novel data that hadn't been previously recorded. For population health, we now have patient to population level data views and health data maps across Scotland. And for personalised medicine, we are now able to allow pharmacists to create customised interventions and treatments that are specific to the individual needs of patients and their requirements. And as part of Life Sciences Scotland and the green value chain, Cohesion is deriving net zero in citizen health and developing and delivering systems that are safer, smarter and more sustainable in health. Thank you very much.
Fantastic, thank you, Ewan. Thank you. And we're now going to hand over to Tiffany from Dynaval.
Hello. So I'm the CEO and founder of Dynaval, Tiffany Wood, and I've set up with my co-founder, Vincent Martinez. And we set up Dynaval, which stands for Dynamic Evaluation. And our vision is to become the expert's choice for motility measurement. We were fortunate to be awarded the IBioIC award for Scottish Edge last year. So currently, when people are doing motility measurement, they're actually tracking from cell to cell. But our technology is completely different because we're measuring the fluctuations of light intensity as they pass through a sample. And so you can imagine you get very fast fluctuations if the sample is moving very fast, and you get much slower fluctuations. And we can obtain measurements of the percentage motility, but also the mean speed over time. And our technology compares extremely well to the £50,000 lab-based equipment that genetics companies are already buying. So we're applying this in the field of semen measurement, where we can provide farmers, vets, AI technicians and genetics companies with the first industry standard across the industry, so that everyone can perform precise measurements of semen quality. And they can make decisions that will enable them to improve the conception rates. It has fallen by over 20% since the 1960s. And if they can restore conception rates to the levels they should be, they'll be able to reduce methane emissions by 10%. But in addition to that, we've also got opportunities in the field of industrial biotech, because our technology can be used to measure the motility of microorganisms such as bacteria and also microalgae. So we can help all of you who are interested in fermentation actually understand the metabolic health of your microorganisms and help you optimize the chemical production and food production that you're working on. One of the nice key features is that we can measure motility over time, and that's a key factor for helping you understand metabolic health. Thank you.
So, good afternoon, everyone. My name is Yusuf Abulhaija, and I'm a senior scientist at Solasta Bio. So, Solasta Bio was incorporated in May 2020, but it started trading in April 2021. So Solasta Bio is an R&D business that works on the interface between biotech and agri-tech. So our aims is to develop and discover new bioinsecticides that are sustainable, and they are insect target for target species. So they can target certain insects and leave pollinator, for example, like bees, untouched. And they are environmentally friendly. So why our work is important? Our work is important because, as you can imagine, there are billions worth of crops are damaged due to insect attack every year. And this usually treated by conventional insecticides. These insecticides, as you can imagine, are not very specific. They can kill target species, but also friendly species like bees, and they are not environmentally friendly. So our technology at Solasta is based on, so we aim to develop greener insecticides, and our work based on insect indigenous peptides. That's small. These are small proteins from the insect's biology itself, and our technology combines both life technology and chemistry. So we've been able to finally attune our peptide properties, so they are becoming biostable, so they are we can tune their biostability so they do not accumulate in nature, and we can control their bioactivity and bioavailability. In terms of the peptide synthesis, our recent SMART grant has enabled us to acquire a cutting-edge peptide synthesizer. This is based on microwave technology, so we have been able to reduce the time cycle for the synthesis, and this therefore reduced the amount of energy consumed in the synthesis, as well as the use of reduce the amount of solvents used. So also we've been able to switch from very toxic, harmful solvents to more green or greener solvents. So our technology is, as I said, target selective for certain insects, leaving pollinators, for example, untouched, and that's environmentally friendly. Thanks very much, and if you have any questions, please find me after the talk. Thank you.
Okay, so if I could invite Tivadar from IntelliDigest, please.
Well, good afternoon, everyone. I'm Tivadar Balaj. I'm the creative design lead of IntelliDigest. I'm currently substituting here instead of our CEO, Ifeanyi Vakano. So basically, IntelliDigest is a biotech company. We are based in Edinburgh in the business incubator at Heriot-Watt. We focus on the global challenges of food system, of which there are many overall. I think everyone knows that, well, probably most people know that roughly 1/3 of food waste, of food produced globally, is actually wasted. And we want to address that. And we develop different technologies. One of our key innovations is the iDigest unit, which is basically can recover bionutrients from food waste, from inedible food waste, through enzymatic processes, and then basically the output of the machine can be used in sustainable farming instead of fertilizers. But we are also looking into alternative applications further, mostly in the areas of insect farming and also feedstock production for fish farms, if I remember correctly. Then we are also addressing the issue of edible food waste, which comes down to the World Food Tracker, which is an application that we developed. It is still being improved on as it's an ongoing process always. But basically, it allows people to keep track of their food waste, also keep track of the nutritional input or the nutritional content of the food waste, food that they are eating. But the tracker itself also contains a campaign that we are running, which is the Plan to Save, which enables the users of the platform to plan their meals ahead, which then aggregates the platform itself, then aggregates the list of ingredients, and then shares a nearby supplier to the consumers directly. So the idea basically is that it would enable the farmers to better plan their food production ahead, being able to streamline their food production, thus leading to reduced carbon emissions and so on. So basically our vision is to ensure that no child goes to bed hungry, and that enables or drives our mission to empower global food sustainability. And that directly translates into the kind of impact that we want to achieve, which is improved health, public health, through providing or improving access to good food for everyone, improving the nutritional content of the food, but then also recovering bionutrients from edible food waste, which the output is then fed back into the production stage. And then, of course, it leads to reducing carbon emissions as well in the food system, but then finally also reducing the edible food waste overall. Thank you.
Fantastic, thank you very much. And if I could just invite Daniela and Natalie now from Smith & McLaurin.
Hello, my name is Natalie Benson. I'm the Product Development Manager at Smith & McLaurin. So Smith & McLaurin has been founded in 1849. So our core business is manufacturing pressure-sensitive label stock for the to supply into label converters. Now, our materials typically used in cosmetics material, personal care, food applications, pharmaceuticals, automotive, and many more. We are market leaders in supplying thermal and digital labels. And in 2021, we developed our first sustainable packaging material called EcoPack. So we are now looking at expanding our sustainable ideas into our pressure-sensitive adhesive ranges and offering recyclable label stock. So after some initial research, we discovered a large amount of packaging cannot be recycled, especially multi-material constructions. A large portion of plastic either ends up in the landfill or in incinerations and therefore lost forever. So seeing the way the world is going with recycling, we decided to branch out into flexible packaging. With the different countries bringing in new legislations into play, like plastic tax in the UK, we got to work developing EcoPack.
So I'm Daniela, I'm the Digital Marketing Manager at Smith & McLaurin. So just a little bit about the product, which I'll pass round. That'll need to get these back at the end, unfortunately, but you can have a wee feel. It's like Dragon's Den. So anyway, this is EcoPack. It is an award-winning, one-side coated heat seal, moisture barrier, FSC certified paper. And it's essentially been launched to market as an alternative to single-use plastic packaging. The sample that you've got is fully HB indigo printed, and it is a protein powder sachet, so it's just kind of one of the first projects that we've worked on with the product so far, but we are looking at alternative angles and routes we can take to market. This example here is just an example of an award that we recently won with one of our converters and printers at the SAMIs Awards that look at kind of sustainability and loads of different angles of sandwiches and cafes and that sort of thing. So we won the most environmental and sustainable award with this material, and I'll just kind of chat a little bit more about the kind of key features as well. So it's got optimal heat seal performance, which is beneficial to reduce carbon footprints and emissions when it goes to the converting and printing process as well, because it has a low heat seal temperature. You can just see some examples here of it in production as well. It therefore reduces overall use of single-use plastics because people don't need to rely on multi-material plastics. They can simply use EcoPack and then put it in the bin, and it's then recycled and fully repulpable at the end of the process as well. It really just allows overall brands and ourselves to reduce overall carbon footprint and make sure that less plastic is used in the overall production in foods and a lot of different applications as well. It's also got really good grease-proof and kind of freeze properties as well, which means that we're looking at alternative routes. So we're looking at kind of ice cream sachets just now, chocolate bar sleeves, and some other projects as well.
Thank you. So really, really big thank you to all of the organisations for sharing the brilliant work that you're doing. And as I said earlier, I'm sure a number of you are sitting there with questions that you have in your mind that you would like to ask of the representatives of the organisations today. So we'll move into a networking session just as quickly as we can. But just some final thoughts. I hope that this has really energised your interest around the industry leadership group and the work streams that are running, that are really moving towards that 2025 vision. Sustainable production group, if you're interested in learning more about that, as I mentioned, there are some colleagues here in the room. It'd be great to share some of the other work that's ongoing in that space. But please do get involved in the industry leadership group, in the sustainable production group, which is just one of those work streams. And the other opportunity, of course, is to engage with Scout. And we mentioned those free opportunities that are available that you can tap into that can really support your organisation, just making sure that we leverage some of that great expertise that can help you along the innovation journey. So I think that's us now moving into networking. So if you do have any questions, please do connect in with the organisations. And thank you so much again for all the people that shared their case studies today. It's a great job. Thank you.